Why, hello, Algebra 2 students. This is Lesson 17. And really, this one has two different objectives. First one says, what are subscript variables? Which is really just kind of an introduction so you don't freak out when you see them. Second one is, how do you solve using angle relations? And we'll kind of go over an example of those and several different things you might see on that. First of all, let's talk about subscripts. First of all, we call these numbers up here exponents. But if you talk about it like in computer language or something, those are called superscripts because they're super and they can fly up in the top and they're up high. They're super. Down here on the bottom, if we put a number down here on the bottom or a letter down here on the bottom, we call it a subscript. So if you're going into like a Word document and you see superscript or subscript, you're putting it either up at the top or down at the bottom. So a lot of times we use variables like x, y, and z, or q and m to represent things that represent something, like the number of dimes, the number of nickels. We might use d or an n. But we can also use subscripts to define them. So that's kind of what I said down here. Subscripts are just used to name similar variables in a way to distinguish them. So maybe if you're talking about like the area of a triangle versus the area of a rectangle, you might say something like the area of a triangle versus the area of the rectangle. Just kind of as an easy way. You're talking about the area for both of them, but you're talking about specifically the area for the triangle or the area of a rectangle. In this next example, we're choosing like x and y for the number of nickels and the number of dimes. We're just going to use n sub n for the number of nickels and n sub d for the number of dimes. So our instructions just say solve this system of equations, which uses the number of nickels and the number of dimes. So you add the number of nickels plus the number of dimes, this is 40, so you have 40 coins in total. And if you say 5 times the number of nickels plus 10 times the number of dimes, you got $2.50 or 250 cents. But notice here it doesn't say solve by any particular method, it just says solve, which means you can pick. You can either solve yours by trying to graph these two. You could solve them by doing substitution, or you can solve them by elimination. Since elimination is our most recent one, and maybe we need a little bit more practice on that, that's how I'm going to solve it, is by elimination. But you can pick the method whenever it just says solve. So since I'm choosing to pick elimination, I'm trying to pick variables that will be eliminated. I could easily eliminate the n sub d or the n sub n. Neither one's very hard. I chose to do the n sub n just because this number is smaller than that number. So I'm going to multiply this top equation by -5. I picked -5 because I'm trying to get to eliminate these. I know -5 plus 5 would give me 0. So I just multiply this top equation by -5, and I got this equation here that I wrote in black. -5 times the n sub n is -5 n sub n, minus -5 n sub d is equal to -200. Now you know the next step, of course, is just to add these two equations. Whenever I add -5 and 5 n sub n's, that just gives me 0. Those goes to nothing. -5 n sub d plus 10 n sub d is going to give me 5 n sub d. -200 plus 250 is going to give me 50. And n sub d then is going to give me 10 because I divided by 5. So again, that is half my answer. The other half would be to just maybe plug that back in. I'm going to plug it back into the first equation. So I'm going to say n sub n plus n sub d, which I found out to be 10, is equal to 40. So that means my number of nickels would just simply be 30 because I subtracted 10 from both sides here. So since this is a word problem, I'd have a word answer. You have 30 nickels and and 10 dimes. Okay, for the second objective, solving equations that involve angles and angle relations, we just kind of have to remember some principles. I'm going to cover more of them here on this next page, but let's just try solving one to see if we can kind of get the basic concept here. Our instructions here are to solve for x and y. Solve for x and y. So first thing I realize is that we have a couple congruent angles. Vertical angles we know are congruent. So I know this up here, 2x plus 5y, is the same thing as 110 degrees. So that would give me the first part of my equation. 20x plus 5y is going to equal to 110. And then, let's see, I'm noticing that this line right here is straight, which means that these three angles here together would equal 180. So I know that 40 plus 110 plus 2x plus 5y is going to equal to 180. Because again, those are straight lines, so that means all three of these angles would have to add up to 180 in order to make that a straight angle. So let's just simplify these a little bit. I'm going to take this top equation and divide it by 5. This is going to give me 4x plus y is equal to, what would that be, 22? And then over here, I'm going to subtract 40 and 110, or essentially I'm subtracting 150. So I'm going to have 2x plus 5y is equal to 30. Again, I'm guessing I'm going to use elimination, so I'm going to multiply this bottom equation by a -2. Again, I'm picking that, so that way -2 times 2 give me -4, and that would reduce to 0 with that one. So then my next two equations, the top one's the same. 4x plus y is equal to 22. My second equation is now going to be -4x minus 10y is equal to -60. Whenever I add those, it's going to give me -9y is equal to, what would that be, 38? -38. Divide by -9. That's going to give me y is equal to 4 2/9, or 38/9. Not super helpful, but that's what it came out to be, assuming that it all might work right. So let's go about plugging in and solving for x. So I'm going to use that first equation, 4x plus y, which is, I'll say 38/9, is equal to 22. That means 4x is going to equal to 160/9, and you can figure that out on your own if you need extra help on that, or ask me. Divide both sides by 4. Will give you 160, and this will be multiplied by 1/4. 4 in that one time goes into that 4 times. This is going to be 40/9. So this is my y, this is my x, so my final answer is going to be 40/9, 38/9. Not pretty, but nonetheless, our answer. Okay, as promised, I just wanted to remind you a few things. If two lines are parallel, this kind of part goes right here, over here with that one. If two lines are parallel, like this one and this one, these blue angles are all the same. So like corresponding, this one and this one, this one and this one, that one and that one, that one and that one. Vertical angles, of course, are the same. Same side interior angles, like this one, are what we call supplementary. They add up to 180. So just kind of some angle relations there you can use. Remember, vertical angles are the same. This one and this one are the same, and that one are the same. Remember, all three angles in a triangle add up to 180. If you have a straight line and a whole bunch of angles, if you just add up all those angles, they would equal 180 as long as it's on a straight line. Same idea if you had a right angle and angles inside of them, all three of those would add up to 90 because that's a right angle there. So just some basic concepts there that hopefully get you on your way in understanding your homework. Your homework is on page 89. You can do 5 through 20 all, and then 4 more of your choice. Good luck. Ask questions if you have them.